Hi students, this is Neeraj Bansal and welcome back to my YouTube channel. The last video we have done on the derivative from the first principle. Now today we are going to do rules of differentiation, right? We have already discussed in the last video what is the power rule, what is the chain rule, what is the product rule, and what is the division rule. I have already explained to you that you need the combination of this in order to um, do the differentiation, right? So today we are going to start with exponential functions. We are already aware that exponential functions are those in which the exponent is variable, right? So let's say I take two examples: y is equal to e raised to the power x and y is equal to a raised to the power. In this we know e is a real number which has a constant value, and this a can be anything. It can be like 3 raised to the power x, it can be 5 raised to the power x, or it can be 7 raised to the power, or anything, right? So this formula is given in the formula booklet for if y is equal to e raised to the power x, dy by dx is equal to e raised to the power of x. And if y is equal to 3 raised to the power x, dy by dx is equal to 3 raised to the power x ln of. So these are the two important laws. Got it? Now let's do something. How do we use the chain rule and all? Let's say if I, y is equal to x, dy by dx is equal to ex. If I have y is equal to e raised to the power x squared plus 2. So what we'll do? We'll take t is equal to x squared plus 2. So it become y is equal to e raised to the power t. So dy by dt dx is equal to dy by dt times dt by dx, which will give me e raised to the power t as it is, times the differentiation of x squared plus 2, which is 2x. My answer is x e raised to the power of x squared plus. I hope this is clear to you. And in the same way, this is true for, let's say if I have um y is equal to 3 raised to the power x squared plus 2. Now y is equal to e raised to the power t, sorry, y is equal to 3 raised to the power t, and then we'll have dy by dx is equal to dy by dt times dt by dx, which will give me e raised to the power t ln 3 times 2x. So this becomes 2x times 3 raised to the power of x squared plus 2 times ln, or you can take ln 3 here. So 2x ln 3 times 3x squared, or you just leave it like that. Let ln 3 be at 3. Clear, perfect. Right. So let's do some questions in this. Let's take these. So find the gradient function of for y equal to, what do you mean by gradient function? Gradient function means nothing but by dx. So if I take the first question a, this is giving me 2ex plus e raised to the power minus 3x. So 2 dy by dx will give me ex. Then if you take it as t, so et times minus 3, which will give me 2ex minus 3e raised to the power of minus. So this is my answer for the first part. Now for the second part, see, basically I have selected these three questions because in the first question, this is a simpler one. You only need to use the chain rule when it is e raised to power minus 3x. Then in the second question, you have to the multiplication rule as well as the chain rule. And in the third question, you need to use the chain rule as well as the question rule, right? So let's come to part B. Let's see what part B is saying. So x squared y is equal to x squared times e raised to the power minus x. So what I'm going to do here is I take u is equal to x squared and v is equal to e raised to the power minus x. So u derivative is equal to 2x and v derivative is equal to negative e raised to the power negative x. Then I simply need to put in the formula y derivative is equal to u derivative v plus uv derivative, which will give me what? U derivative is 2x times raised to the power minus x plus uv derivative. What is x squared times minus e minus x? This becomes 2x e raised to the power minus x minus e raised to the power minus x. If you want to take the common and then solve it further, that's fine. But if you leave it here, there is no problem unless you are specified that you have to simplify it to a certain equation. Got it? Let's move to part. So my part C is saying e raised to the power 2x by x. Y is equal to e raised to the power 2x by x. U is equal to e raised to the power 2x. V is equal to x. So u derivative is 2x and v derivative is 1. Now you need to simply substitute it into the formula. Y derivative is equal to u derivative v minus 2v derivative over v squared, which will be nothing but x times x minus e to the power 2x over x squared. Give me 2x e 2x minus e 2x over x squared. Again, if you want to do some kind of a simplification, that's fine. If you are comfortable, if you don't want to do, that's also fine, unless specified, right? So this is all about exponential functions. Let's do a couple of questions from then we come to log function, right? So let's talk about log function. So when we are talking about log functions, we need to work on the two. One is ln x and second is log x. Let's say my base is 5. So what happens? Again, this is given in the formula booklet. If y is equal to ln x, dy by dx is equal to 1 by, got it? But what about if my y is equal to log x to the base 5? In this case, it is not 1 over x. 1 over x is the differentiation of ln x. So we have to convert it into ln x by using the law of logs. This will become ln x over ln 5. Now, if I differentiate it, y derivative is equal to, so ln 5 is a constant. So it will come out of the differential d by dx of x, which will give me 1 over x and 5. This is my final answer. Yeah. Now let's take some questions. So now if I have this, y is equal to ln of 1 minus 3x. So what I'll do, I'll take 1 minus 3x as t. So this becomes ln t. dy by dx is equal to differentiation of this, which is 1 over t. times differentiation of 1 minus 3x, which is negative of 3. So this will become negative 3 by t. So this will become negative 3 over 1 minus 3x. So this is my answer. Got it? So this is how we'll proceed. And it will take part in part B, y is equal to x cubed. In this case, you need to use the product. U is equal to x, e is equal to ln x, u derivative is equal to x squared, and v derivative equal to 1 by x. Then you simply need to put it into the formula. Y derivative is u derivative v plus v derivative, which derivative squared times ln x plus ub x cube type 1 by x e squared ln x plus x squared is my answer. Perfect. You got it, right? Let's do. Yes, this again is an important concept. See, most of the times it is easier to use the laws of logs for finding this kind of differential, right? So y is equal to, you need to simplify this. Y is equal to ln of x times minus. If I use the law of logs, what is the law of log? Ln of ab is equal to ln a plus ln. I'll use this here. Y is equal to ln of x plus ln of e minus. This becomes 1 by y derivative plus, if I take it as t, so it will become 1 by t times differentiation of e minus x, which is negative 1 negative x. So this will become 1 over x minus e minus x over t. What was my t? My t was minus x, right? Yes, because I have taken here e minus x as t. So this becomes 1. 1 over x minus 1 is clear. We are done with this. We are done with exponential functions. We are done with logarithmic functions. Now we will talk about, let's say, trigonometric function. Yes. So let's talk about trigonometry. Trigonometric functions again are important. So I'll explain you once how trigonometric functions works. See, basically you have y is equal to sine x, then y derivative is equal to cos x, and if y is equal to cos x, y derivative is equal to negative sine. Is this clear? Right. Now we have other trigonometric functions as well, like tan x, sec x, sec x, and cot x. How we will simplify? Let's talk about first tan x. Tan x can be written as sin x over cos, right? So let's take sin x equal to cos x u derivative is equal to cosec, and v derivative is equal to minus. You have u derivative v minus uv derivative over square, which will give me u derivative will be cosx times cosec minus sin x times minus sin over cos squared x, which will give me cos square x plus sin square x over cos squared x. Using the identity 1 over cos squared x x squared. So differentiation of tan x is sec square. Got it? Same way I'm doing for sec x. So if I do for sec x can be written as 1 over 2 is equal to 1, v is equal to cos x, u derivative is 0, and v derivative. Substituting it in the formula, u derivative v minus uv derivative over v squared. This will give me u derivative v 0 times cos x minus uv derivative 1 times minus x over cos squared x, which will give me sin x over cos squared x, which can be written as sin x over cos x times 1 over cos x. This is equal to tan x times sec x. This becomes sec x tan x. Got it? Now same way, so I have done it for tan x and sec x. Same way you can do it for cosec x and cot x. The answers will be y derivative is equal to minus cot x sec x, and for y is equal to cot x, answer will be y is equal to. You can try it with the same method which we have adopted for tan x and sec x. All right, very good. Now let's do some questions based on, so you will understand it, right? Right. As you can see, in this case, you have to apply the product rule. Y is equal to x sine 2 is equal to x, e is equal to sine x, u derivative is equal to 1, and v derivative cos x. Just put in the formula y derivative e plus uv derivative, which will u derivative 1 times sin x plus x cosx sinx. Perfect. Then we have y is equal to 4 tan squared x. What you can do is in this you have to use the chain rule. So 4 tan 3x whole square. So in this case, you need to understand one thing. First, you need to differentiate the whole thing. That means it will become 4 times 2 times tan 3x. Then differentiate tan 3x, which will be sec squared 3x. And then differentiate 3x, which is 4 times tan 3x. I hope this is right. Then we take cosec 3x. Again, it's simple. Sec. So the formula for cosec 3 sec x is minus cosec x minus cot x. So if I'll take, first I'll differentiate the whole thing, minus cosec 3x times cot 3x. Then you have to differentiate that it make sure that, and then this is the differentiation of 3x's. My answer will become minus 3 cosec 3x times cot. Is clear? Perfect. Let's move to the last question which we will do today in order to make everything. Y is equal to cot x by whole half. So what we need to do, first we'll differentiate this whole thing, half cot x by 2. Then we will differentiate cot. So what is the formula for cot? Minus cosec. So I'll take my minus here. Then cosec squared x by 2. Got it? Times differentiate x by 2, which is, so my answer finally will become negative 1 by 4 cot x by 9 x square x by 2. Right? So this is my final. I hope this is clear to you, right? Just watch the video 1 or 2 times and then practice math. As usual, when I'll come live, I'll give you some worksheets which will be of the standard of IB. So right, right. So next, rest we'll do in our next video. We'll make one more video on differentiation with and the higher derivatives and the implicit differentiation. Got it? So please subscribe to my